Okay, so we're going to continue 3.7. What we ended up last time was talking about the formula for elasticity. Okay, elasticity, and we use this idea. Okay, that my notes. Oh, there. Okay, that there's things that are inelastic and there's things that are elastic. Okay, and okay, and so when revenue is increasing, going up. Okay, when revenue is increasing, we say that that's inelastic. Okay, sales are revenue is increasing, it's inelastic, and when it's decreasing, we say that it is we say demand is elastic. Okay, so inelastic when the revenue increases. Okay, elastic if it decreases. Okay, okay, so you can maybe think of inelastic, inelastic. No, this is a really bad pen. Okay, so inelastic, think of it as unaffected. Okay. Okay, unaffected by price. Okay, so revenue. Revenue is really unaffected by price. Your revenue actually is going up. Okay, whereas elastic, your revenue is affected by the price. By the price. Okay, so what, let's ask this question, what will maximize my revenue? Okay, that's kind of the question that we're going to answer today. It says, okay, so if it's inelastic, the demand is not as sensitive, but if it's elastic, then the demand is sensitive to price changes. Okay, inelastic, think of it like, you know, it's not going to change, your revenue isn't not going to change much to the demand. Okay, it's inelastic, it's unpliable. Okay? It doesn't change much. Okay, but elastic means that that your revenue is pliable and your revenue is going to decrease. Okay, so think of it as like, you know, and again, the inelastic, think of it as milk, and elastic, think of that as Starbucks. Okay, so inelastic milk, why? Because again, it doesn't matter if we're going to go from $2 to $3, people are still going to buy their milk. Whereas, and that's more of an essential item, as opposed to an elastic demand, an elastic elasticity is like Starbucks, where, you know, you charge an extra $1 for your cup of coffee. You know, people may not be as inclined to buy that cup of coffee. Okay, no, well, what's going to maximize the revenue? What elasticity maximizes our revenue? Right. So what is the elasticity that maximizes our revenue? Let's talk about that. Okay. So let's look at our function. Let's look at number 1 here. Okay, the function that we were working with before was this demand function, dx, okay, is equal to 120 minus 2x, right? We said that's the demand function that we're working with. Oh, okay. Okay, and so if this is the demand function, right, then what's the revenue? What's the revenue function? Right, and what did x represent? D is in units. Units bought, right? Units bought. And X is in what? Is the price? I think it's price, right? Is that right? Let me make sure. Let me go back a page here. X is price per unit. Yes. Okay, this is quantity. Maybe I'll just call it quantity. Some books do call it this D. It's they call it Q instead of D for quantity. So D here is quantity, and X is price. Okay. Well, how do you find revenue? How do you find revenue? Any ideas?
You can subtract the profit from the cost.
No, we have a demand function, and we have price. How can we relate demand, price, and revenue?
Will you multiply them?
Yeah, because say I have 100 iPhones at $500, how would I find my revenue, right? Wouldn't I multiply the amount of iPhones that I sold times the price that I sold them at? Wouldn't that generate my revenue? Does that make sense?
Yes.
Okay, so revenue is D of X times X. That's my revenue. Oh, okay. So the revenue here is going to be, okay, X times D of X. But what is D of X? D of X is 120, okay, minus 2X. Okay. And so we want to know what's going to maximize my revenue here. Okay. So what value of X is going to maximize revenue? Okay. So I'm going to distribute this. This is going to be R of X is equal to 120X minus 2X squared. And now, how do I maximize something? How do I find the maximum value of something?
Derivative.
Yeah, take the derivative and do what with it?
Equal it to 0.
Yes, very good. Thank you, Mario. Okay, take the derivative and set it equal to 0. Okay, so what's this derivative? 120 minus 4X is equal to 0. Toss the 4X to the other side. 120 equals 4X. Divide by 4. And I get X equals, I screwed up here. This isn't 2X. This is 20X. I'm sorry. Is that right? Yeah, sorry, that's 20X. It should be 20X. It's all good. So I don't want to end up with 30. I want to end up with 3. 20X. Okay, and so this ends up with, this is 40. So 40X divided by 40. Okay, and so X equals $3. $3. Okay, so that $3, okay, is going to be is the price. This is the price. This is the price that will maximize revenue. So I want to sell this thing at $3 a gallon or $3 a cup or whatever it is that we're selling. Revenue, I can't spell revenue. Okay. Revenue. Okay, this is the price that will maximize revenue, right? Okay, and so we're going to go what is the max revenue? Well, let's plug in 3. R of 3 is equal to 120 times 3 minus 20 times 3 squared. Okay, nice. This is going to be 360 minus 20 times 9.
180.
20 times 9. Okay, and this is going to be 180. So this is 360 minus 180, which is 180. So that's my max revenue. So my max revenue will be 180. I will sell. Okay, I will sell $3. We'll do coffee. We'll do cups of coffee. Okay, $3 cups of coffee. To how many people? How many people will buy my coffee? Any ideas? Well, if I make 180 bucks and I sell them for $3 a piece, how many people will buy my coffee?
60.
60. Thank you, Mario. Mathematical genius. You are. Okay, 60 cups to 60 people. Okay, for a maximum profit of $180. Oh, okay. We're like, okay, well, what the hell does this have to do with elasticity of demand? Well, let's see what we did here. In order to find revenue, we took the demand function times x, right? Oh, okay. Okay, and we said, well, let's take the derivative of this thing. R prime of x is equal to, this is going to be a product rule. Derivative of the first times the second plus the derivative of the second, which is 1, times the first. Okay. Okay, and we want that to be equal to 0. Okay. So this is going to be d prime of x, okay, times x, times x plus d of x is equal to 0. Okay. Okay. So let's see what we get here. We're going to plug this in. I'm gonna solve for dx in this case. Okay, let's solve for dx. So I'm gonna toss this guy to the other side. That's going to be dx is equal to negative d prime of x times x. Does that make sense? So far, so good. Okay. Maybe I'll put some brackets here just to separate out the x's. Okay. But what was the elasticity of demand? Elasticity of demand was negative x d prime of x all over dx, right? Wasn't that the elasticity of demand function? You're like, sure it was. Okay. Yes, this is what it was from 2 days ago. Okay, makes sense? But what demand is going to maximize my revenue? What demand maximizes? Doesn't this demand maximizes my revenue? Okay, maximize my revenue. Okay, so I'm going to plug this thing underneath. Ooh, look at that. I'm going to get e of x is equal to negative x d prime of x all over negative d prime of x times x. What happens? Cancel, 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 cancel. 1. Oh, that's kind of cool. So the elasticity of demand that maximizes revenue is 1. So if I can get my elasticity of demand to equal 1, then I win. Then I know that, oh, I'm maximizing revenue. Okay. Oh, that's kind of good. So elasticity of demand, which is negative x d prime of x over d of x, if I set that equal to 1, this will give me, okay, and I solve for x, this gives me my max revenue. There you go. That's what we want to know. We want to know, how are we going to maximize our revenue? I want the money. I want the ching and the bling bling. Okay. I don't got any Star Wars chains yet because I'm poor. I'm so poor I can't afford an R. Why it's poor instead of poor, forget it. Okay, that's it. The baguettes. Okay. So it's all good. It's all good in the hood. So, or so I'm told. So I'm told. Okay, so let's figure out the elasticity of demand here on some stuff. Okay. If the elasticity of demand is less than 1, if it's smaller than 1, then we say that this is inelastic. Okay, which means price does not negatively affect demand. Okay. And then if E of X is greater than 1, then we say that this is elastic. And we say that price does negatively affect demand. Okay, well, let's look at our demand function here, d of x. Okay, our demand function was 120 x, 120 minus 20x, I mean 120 minus 20x, right? Our revenue function was 120 minus 20x times x. Okay, and what's our elasticity of demand function for this guy? Well, what's d prime of x? This would be negative x d prime of x all over d of x. Okay. So we're going to go negative x. What's the derivative of x? Well, that's just negative 20, right? So that's times negative 20. Okay, all over the original function, which is 120 minus 20x. Okay. So what does this become? This becomes 20x over, I could factor out a 20x if I wanted to. This would be 20, or sorry, just 20. 20 over 6 minus x. Cancel out the 20. And I'm left with x over 6 minus x. Okay, so I have these three functions. Okay, these three functions, I'm going to graph these three functions. Okay, I'm going to see what the heck is happening here to these three functions. Where are things elastic? Where are things inelastic? And where's our break-even point? Where are we going to maximize our revenue? Okay, what's our minimum revenue? Well, that's when you have no customers, zero, zilch. Okay, or the price is so high, either the price is zero, which means you're not charging enough, or the price is so high, like it's $20 a glass for a cup, that nobody's walking through your door. So you want to hit that sweet spot, right? You want to hit that maximum revenue where you're not charging too little, you're not charging too much, you're just charging just enough to maximize your revenue. So let's see what happens when we plug these in. Okay. To Desmos. See it in action. Okay. So let's go to Desmos. Desmos. House. Okay. Okay, so the first one that we want to do is our demand function. What's our demand function look like? Well, it's d of x equals, okay, 120 minus 20x. Oh, like this. Okay, so I gotta. Okay, so $6. I gotta zoom out, zoom out. Okay, zoomage, do my zoomage here. Okay, let's see if I can set this up. Okay. So I'm gonna have a point at 120. I'm gonna have a point at 6. Okay. I want it to go wide. Why does it zoom on me? I don't like that. Let's go to settings. Let's make it go wide. Okay, let's do projector mode. That's good. Okay, and then it says, where do you want your X values to be? Well, I want my X values to go from 0 to 7. Okay, boom. Look at that, that's better. Okay. Oh, that's nice. Okay, 0 to 7. Good. Then I can scoot it over just a little bit here. So there's my 0.0120. There's my 60, and I got my demand curve. Look at that. Sweet. Okay, now what do I want? I want my revenue curve. I want my revenue curve. So let's do our revenue curve here. What was our revenue? It was the demand times X. Okay. So R of X is going to be equal to 120x. I'm just going to distribute 120x minus 20x squared. 20x squared. Oh, okay. I got to squash this just a little bit. Squash just a little bit. Look at that. What's that? That's our friend, the parabola. That's our revenue function. And we have a maximum value. Oh, that's kind of cool. Maximum value. Where's the, whoa, stop. Don't be doing that. Where's the maximum value? Well, the maximum value is at 3,180. Look at that. Exactly. So the max occurs at 3,180. Nice, nice, nice. Okay, so now let's look at our elasticity function. Okay, let's look at the elasticity function, E of X, and we said that was equal to X over, oops, not that, over 6 minus X, right? 6 minus X. Whoosh, look at that. Okay. Okay. So what is this point here? That's interesting. Those are interesting points. 5, 5, 5. Okay. So, okay. Now, what value was our break-even point? The value at our break-even point was 3, right? That's where our revenue was maxed. So I'm going to zoom in. I'm going to get rid of these points. I don't want you to go away. Okay. I'm going to zoom in. Okay. And say, and I want to find out what, maybe I'll put in X equals 3 here, just as a reference. X, nope, little x, small x, X equals 3. Ooh, look at that. That's nice. Okay, X equals 3. What's the demand function at X equals 3? 60 people. 60 people want my Starbucks. Okay. How many? What's my revenue? It's 180. Nice, 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 nice. And what's my elasticity? What's my elasticity? Oh, look at that. It's 1. It's 1. What happens if I move? If I move smaller over here, I get a number smaller than 1 for my elasticity. If I move past that break-even point, that number, the elasticity, that's the Y value, is bigger. And then it just goes whoosh. Okay. This elasticity is like basically nobody's gonna buy your crap. Okay. If your elasticity is way up here. Okay. Where are you gonna maximize your revenue? Boom, right there. And your elasticity is 1. What does an elasticity less than 1 mean? It means that your revenue, you still have room to make more money. It means that it's inelastic. If I'm over here in my revenue, that means I'm inelastic, which means that a change in price is only going to make more money. a change in price is only going to make me more money. It's not until I pass the maximum revenue point where I start losing money, right? If I start charging, you know, $4 a gallon for my milk or whatever, I'm going to start losing money. Boom. $5 a gallon for milk. You can do this with anything. Think of it as with gas prices too, you know? Basically, a gallon of milk and a gallon of gas are the same. You guys probably didn't know that because you guys probably don't even shop for yourselves. Okay, but those of us that do shop for ourselves, okay, we know that, hey, you know what? That gallon of milk and that gallon of gas, that's about the same price every time. Okay, because, you know, especially in California, where they tax the hell out of you. And they're like, oh, there's a transportation cost on your gallon of milk. Oh, there's a, okay, there's, okay, is it about $1 more right now? I don't know. Are you, yes, may I help you? I'm always teaching. I never leave this seat. Last time you were awake?
I thought you said you're done for the day.
I took a nap. This is my last class for the rest of my life. I'm just kidding. So what, did you need something?
I just thought you weren't working.
Oh, okay. You want to say hi?
No.
I didn't think so. That's my son, by the way. He came in.
So did you miss the presidential debate?
Did I miss the debate? I don't think it's happening right now.
Right this second.
I'm just gonna TiVo it and watch it later. So it's all good.
It happened exactly an hour ago.
It happened exactly an hour ago.
Yep.
Oh. Dude. Okay.
Let me
Well,
know.
don't spoil it for me.
I mean, I just woke up. So.
Yeah. Well, we can watch it together in about a half hour. I'll be done in about a half hour. Okay. Pardon me. Excuse me. Life happened. My bad. See. So, don't get any ideas. Don't be watching the debate and not watching me. Okay. Don't get. You turn that off. Okay. Eduardo, I see you. I see Eduardo. Turn your television off now. Okay. Stop it. Okay. It's not even important. Okay. This stuff is important. Okay. This is gonna save the universe. Okay. Those two guys on the stage that are like older than shit. You really think they're gonna save the universe? I don't know. Okay. I just whatever. Okay. This is the good stuff. Okay, this is the good stuff. Okay, so at any rate, before I was so rudely interrupted, inelastic means that your revenue is going to you have space to charge more before you start losing money. Elastic means that you're losing money if you go up in price. Okay, that's the bottom line for that. Okay. Okay, let me see if there's anything else that I need to talk about. Okay, so yeah, what is the elasticity at $2? What's the elasticity at 2? At 2, it should be 0.5. Yep, it's 0.5, which is less than 1. So if I charge $2 a gallon, I'm just going to say this, that the elasticity, this will be the last thing that I say on this. Okay, the elasticity at $2 a gallon, okay, is going to be 2 over 6 minus 2, which is 2 over 4, which is 1/2. Okay, so is that elastic or inelastic? It's inelastic. Okay, so $2 a gallon, we're inelastic. It means we could charge more and demand is not going to go down. We're not going to lose demand. Okay. $3, what's the elasticity? It's 1. This is it's not elastic or inelastic. We say that this has unit elasticity. It's unit elasticity. Okay, it's not inelastic or elastic. We say it's unit elasticity, and this gives us our max revenue. Okay, that gives us our max revenue. Okay, and then E of 4, okay, is what? This is going to be 4 over 4 minus 2. So this is 4 over 2, which is 2. That's, this 1/2 was less than 1, so it was inelastic. Okay, this 2 is greater than 1, so it's elastic. Okay, so that's all I have to say about 3.7. Okay. So, you guys ready to go into 3.8? Okay, 3.8. Okay. Okay, 3.8. Implicit differentiation. Okay, implicit differentiation. Okay, so implicit differentiation allows us to find y prime without solving for y by using the chain rule. Okay, so sometimes we don't want to solve for y because it's just a nightmare. Okay, for example, if I had something like x equals y squared, how could I solve for y? Well, I could solve this for y, but I don't really want to because I'm going to end up with two functions. So I would get y equals plus or minus radical x. So I get y equals radical x, and I would get y equals negative radical x. And then how am I going to find the derivative of that? You're like, y prime? I don't know. What the hell is y prime there? So what this allows me to do is the chain rule allows me to implicitly differentiate this. Think of this as, okay, x equals y squared. Okay, what's the derivative of x? What's the derivative of x? 1. What's the derivative of y squared?
2y.
2y, but, and here's a big but, here's the big but, okay? But y is a function of x. Think of this as y of x, right? Y of x. So what happens when I take y of x? Well, I would have to do the derivative of the outside, right? So this is like y of x, right? So derivative of the outside times the derivative of the inside, which is y prime. Ah, look at that. Okay, so that, oh, look, that's where we get our y prime from. Oh, okay. So what is y prime? Divide by 2y. I get 1 over 2y is y prime. Oh, okay. So this is called implicit differentiation. Okay, implicit differentiation. Because y is a function of x, I just do the outside and then the inside. Okay. So we'll call this number 1. Okay. Differentiate this bad boy. Okay, number 2. Number 2. Let's try another one. Let's differentiate y cubed equals x. How would we do this? Maybe we'll do x squared this time. Just spice it up. Spice it up. Y cubed is equal to x squared. Okay. So how can we do this? This would be 3y squared y prime is equal to 2x. Divide by 3y squared. And we get y prime is equal to 2x over 3y squared. Nice. Okay. Okay, let's do a real example here. Let's do a real cool example. Okay, number 2. Okay. A. Find dy dx, okay, basically y prime, of this function, y cubed plus x squared y to the 5th minus x to the 4th is equal to 11. Okay, we'll make it negative 11. Spice it up. Okay, so how are we going to implicitly differentiate this? So we gotta take the derivative with respect to the rules that we have. So this is the power rule, right? So what's the derivative of y cubed? Well, that's 3y squared. And every time I take the derivative of y, I have to multiply by y prime. Y prime. Okay, plus, okay, this is going to be 2x squared y to the 5th. This is going to be, treat this as a product rule. So derivative of the first, 2x times the second, plus the derivative of the second, 5y to the 4th y prime times the first, x squared, okay, minus derivative of x to the 4th, that's 4x cubed, is equal to 0. I'm going to go 0 there because the derivative of negative 11 is 0. Okay, so this thing here, okay, is right there. That's the derivative of that. That corresponds to that. And that corresponds to that. Now, what am I going to do? Well, I'm going to put everything that has a y prime on one side and everything that doesn't have a y prime on the other side. So I'm going to collect y primes. I'm going to go 3y squared y prime plus 5y to the 4th y prime x squared, okay, equals, I'm going to push this guy to the other side and this guy to the other side. They're going to change signs. So this becomes 4x cubed minus 2xy to the 5th. Now I'm going to factor out my y prime. So y prime times 3y squared plus 5y, I'm going to put the x squared first, 5x squared y to the 4th is equal to 4x cubed minus 2xy to the 5th. Okay. So y prime is equal to, divide everything by that guy, and I get 4x cubed minus 2xy to the 5th all over 3y squared plus 5 x squared y to the 4th, and that's the derivative. Okay, that's the derivative. Now, let's do part B here. Find the slope of the tangent line to what? To y. Okay. Maybe we'll find the slope of the tangent line. Okay, that's fine. 2y cubed plus x squared y to the 5th minus x to the 4th equals negative 11. We're going to find the slope of the tangent line to this at the point, okay, at the point 2, 1, okay, at the point 2, 1, 2, 1. So I know I'm given that there's a point on this 2, 1, okay, and so I want to know at that point, what's the slope of the tangent line? Well, that's y prime. So I'm just going to plug in my x's and y's here. So x is 2, y is 1. So it's going to be 4 times 2 cubed minus 2 times 1. Oh, sorry, 2 times 2 times 1 to the 5th power all over 3 times y squared, which is 1 squared, plus 5 times 2 squared times 1 to the 4th power. Okay. So let's see what's that. Y prime is equal to, why do I have this out? Okay, y prime is equal to, this is going to be 4 times 8, which is 32, minus, this is going to be 2 times 2, which is 4, so that's 4, okay. All over, this is going to be 3 plus, this is going to be 5 times 4, which is 20, I think. Okay, so y prime is equal to 28 over 23. Okay, so that's the slope of the tangent line. Okay, the last part of this, okay, is find the equation of the tangent line. Find the equation, part C here, of the tangent line, okay, to that function, once again, to, I'm just going to call it, okay, to y cubed plus x squared y to the 5th minus x to the 4th equals negative 11, to this function, okay, find the equation of the tangent line to this thing through 0.21. Okay, so we want to know what the equation. Well, let's use point slope form. Y minus y1 equals m times x minus x1. Okay, so this is going to be y minus y is 1. M is the slope that we found here. That's the slope of the tangent line. That's 28 over 23 times x minus 2. Okay, so we could distribute if we wanted to. Y minus 1 is equal to 28 over 23x minus, this is what, 56 over 23. Add 1. Okay, and we get y equals 28 over 23x. 1 is 23 23s. I know that, okay, from elementary school. 23 over 23 is 1. So I'm going to say negative 56 minus 23. What is that, 33? So this is minus 33 over 23. That's my equation of my tangent line. Okay. So let's prove this. Let's prove it. Let's prove it using a computer. Okay. So how are we going to do that? Well, I'm going to go to Desmos, which is my computer. Okay, and I'm going to plug in this function. This function. Okay. This dysfunction. More like it. Okay, y to the 3rd power. Okay, plus x squared y to the 5th. X squared y to the 5th. Okay, minus x to the 4th. Minus x to the 4th equals negative 11. Woo, that's kind of weird. Okay, there's my spicy function there. Okay. Spiceroo. It's interesting. Very interesting. Okay, and now I want to know, well, what's the, at 2, 1, do I have a point at 2, 1? Where'd my mouse go? Oh, there it is. Okay. Why is it not giving me a point? Let's do the 0.21 here. Boom, there's my 0.21. Okay. Okay, so looks like it's that 0.21. What do I want? I want the tangent line to this, right? I want the tangent line to this. Okay, so what's the tangent line going to look like? Why is it so wide? Let's make it less wide. I hate you. Okay, the x-axis, I want to go from 0 to 4, I think. 0 to 4. Okay, and the y, the y's are way too wide. The y, I want to go from like -3 to like 3. Not -2, whatever. Okay, that is a weird function. Look at this weirdness here. It's like wackadoo. What a weird function that is. But that's okay, because I want the equation of the tangent line to this thing. And what did we say that was? We said that was y equals 28 over 23x. Okay, oops. X, okay, minus 33 over 23. Oh, look at that. Look at that. Look at that. Goes through my points there. Okay, maybe I'll get rid of this one. Okay. So tangent at that point, 2, 1, boom, and it does go through. Okay. Those are other intercepts. Let me do this. Let me do this real quick. Let me do x equals. What do I want? X equals 2. X equals 2. Boom. There we go. Okay. Oh, 0.21. Okay. So some good points there. Okay. So we're coming along this line. Okay. Line, and we're at the 0.21. Okay. If we come along this function, why is it not allowing me to graph it? Maybe it's too intricate, I guess. I guess you can only do that if you're solved for y. But at any rate, hopefully I've proven to you that that's the equation of the tangent line to that freaky function. Okay, and we use that by implicit differentiation.